Welcome to Brain Vision.
This is chapter 27, problem number 74. We have a bar that is, let's draw the diagram that is given to us. That is at an angle, and it has the current towards the point P. It's embedded in an external B field. Its direction is into the page. And one end is attached with a piece of string to the wall, and let's show the tension like this, and there's always gravitational force acting on this bar. And we have, since this is the direction of the current due to the external magnetic field, we're going to have a magnetic force acting on the bar. So we have three forces acting on this bar. So let's look at the torques that each force would generate. Tension would generate a counterclockwise torque. F sub B would generate a clockwise torque, and F sub G gravitational force would generate a torque that is also clockwise direction. Now let's write, if the rod is not rotating, the net torque on it has to be equal to 0. So the torque coming from the tension minus the torque due to gravity minus torque due to magnetic field then has to be equal to 0, right? From here, the torque generated by the tension has to be equal to the torque generated by the gravitational force and the magnetic force. This is the main equation that we're going to use in order to find what tension T is, right? So let's write down what the torque generated by the tension would be. It would be tension times the length of the bar times the sine of the angle between T and L vector, right? So then when we look at the angle, that might be a little tricky. So if this is theta, this is given to us in the problem, the angle between R and T, like we're gonna have to carry the T here just to be able to see the angle between them. So as you can see, this angle is 180 minus theta. And when we're writing the torque generated by the gravitational field, then we're here, right? We have F sub G times L over 2, because that's the distance from where the force is applied to the pivot point, times the sine of the angle between F sub G and R. Again, we're going to have to carry the F sub G here. From there, you can see actually the angle between the two is theta plus 90 degrees. So theta plus 90 degrees. And the torque generated by the magnetic force is from a previous problem. We were advised to use that expression. So it would be I times B times L squared over 2. Now we're going to put all these three expressions in this equation, and then we're going to isolate T. Now when we do that, T times L times sine of 180 minus theta then is going to be equal to mgl over 2 sine theta plus 90 degrees plus IBL squared over 2. Now, then in order to find the T, if we divide both sides by L sine 180 minus theta, and do the same here, L sine 180 minus theta, then we have the expression for the tension. So it's going to be, let's plug in the numbers while we're at it. The mass was 0.084 kilograms times 9.8 meters per second square. 9 plus 0.18 meters. I did the conversion. And here the sine is going to be then 53 plus 90 degrees divided by half, plus current is 12 amps. The magnetic field is 0.12 Teslas. The length is 0.18 meters squared over 2. Then what we have is 1 over length is 0.18 meters times sine of 180. Sorry, I'm going to write it here, 180 minus 53. So if we do everything, if we do this calculation correctly, then potentially we're getting something like 0.47 newtons. Now, also in the problem, it's asked that we calculate the torque generated by the magnetic field. So it's going to be IBL squared over 2, something that we already along the way calculated. So it's basically answer to this part. Maybe I don't really need to rewrite. You can plug this in here. So what we're getting is something like 0.023 Newton meters for the torque generated by the magnetic field.